Okay, so what we're going to look at is the span in and what vectors span in means. And we're going to look at this question. Show that these vectors, 1, 1, 1, 2, 1, 1, and 0, 2, 1, form a basis for R3. Now, when we're talking about a basis for R3, this is what we're really looking at. This is the most natural basis for R3. It's a vector that's 1 unit in the x direction, 1 unit in the y direction, and 1 unit in the z direction. And the whole of R3 can be made up of some mixture of these three vectors. So the point 3, 4, 6 might be looked at upon that it's 3 lots of this vector plus 4 lots of the second vector plus 6 lots of the third vector. And that would give us that point or get us to that point. So this is the most obvious and the easiest one to work with, but any sort of three vectors that are independent, in other words, a vector going up this way, like the y-axis, a vector going off this way, like the x-axis. Now, normally we would say that the z-axis might come out this way to give us a 3D, and that would be these three vectors. But this z-axis could be just a little bit off the other two. So still in the not in that plane, but coming in or out of the screen. But it doesn't have to be at right angles. It could be that could be the Z plane. It might be harder to work with, but it would be, as long as you consider that a plane. That is not a line in the XY axis. That's a plane. So it's coming out of the screen towards us a bit. So really, when it says show that these three vectors form a basis for R3, basically what that's saying is when we set up our little matrix, where the first one is 1, 1, 1, 2, 1, 1, and 0, 2, 1, that nothing weird should happen, that these three should be independent of one another. If we get it into row echelon form, what we should be able to see if we get it into row echelon form is zeros here, and a number here. It might be A, B, and C down here. It doesn't matter. It doesn't really matter about these numbers. But if we get a 0 here, then the three numbers or the three vectors aren't independent. This one is dependent on these other two. It's some combination of the other two. So let's put this into row echelon form. And I've purposely made it fairly simple. We're not going to touch we'll write it out again. So I've got a bit of space. So let's say that R2 is going to become R2 minus R1. So we're not going to touch the first vector or the first line there. Sorry, 0 to 1 to 0. This second line is going to be R2 minus R1. So 1 minus 1 gives us 0. 1 minus 2 gives us minus 1, and 2 minus 0 gives us 2. And fairly similar for the second one, R3 minus R1. Now, I just picked these three vectors at random, so I'm hoping that they have a basis, but if they don't, that's okay as well. It will show us something else. So row 3 is going to be row 3 minus row 1, so 1 minus 1 is 0. 1 minus 2 gives us minus 1, and 1 minus 0 gives us 1. Okay, so we've got that first little bit. We just need to get rid of this one now. So let's look at row 3. And what's it going to be? Row 3 minus row 2. So we're just looking at row 3 minus row 2. And I'll write it over here. So we're not touching the top one. 1, 2, 0. 0 minus 1, 2. We haven't touched them. All we're doing is changing that bottom one. So R3 minus R2. 0 minus 0 gives us 0. That's the whole point. Minus 1 minus minus 1 gives us 0. Again, it's the whole point. And 1 minus 2 gives us minus 1. So even though that's, yes, that is in row echelon form, because we've got zeros here and the leading terms, there's a leading term in each row. But because it's in this, these are independent vectors. And because they're independent, it means that it is a span for R3. If we looked at a fairly obvious other one, and I'll try to get this, I should have probably thought about it before, but let's consider these three vectors. The vector 2, 2, 2, the vector 1, 2, 1, and the vector -1, 0, -1. Now, I'm assuming that these are not going to be a basis for R3 because I can see that this vector is just going to be this vector minus this vector. So I would assume that something weird's going to happen here. So if we set up our little matrix again, 2, 2, 2, 1, 2, 1, -1, 0, -1. And we try to get it back down to echelon form. Now, this is going to be quite easy. R2 minus R1. So that's going to be the first thing. We're not going to touch that first line. 2, 1, -1. This second one's going to be R2 minus R1, which is 0. 2 minus 1 is 1. 0 minus -1 is 1. And the same thing here, it's going to be R3 minus R1. So 2 minus 2 is 0. 1 minus 1 is 0. -1 minus -1 is 0. And because of this, as I said, something weird's happened. And now we've only got two vectors or two lines and three unknowns. So these three vectors or one of these vectors, they are a dependent set. This is a dependent set. Because this line here gives us a line of 0. So it's a dependent set. This line here is dependent on the other two somehow. So that would not, these three vectors would not give us a span of R3. Thanks.
Cool.